Hello and welcome to this video where we'll come into matplotlib. So here we will use matplotlib for drawing graphs, so drawing charts. And there's a lot of different charts that you can draw with matplotlib, but this will just be some fundamentals. And in previous videos, you have touched up on matplotlib a little bit, but now we will go in more in a little bit of detail, but not so much detail. If you want to learn more, there's a data visualization course that I have created where you will use matplotlib and go really into depth and how to use it for creating beautiful visualizations for data storytelling. But here is just some basics, and we'll learn about the MATLAB style interface and also the object-oriented interface. Yes, so see you in Visual Studio Code. So here I am in Visual Studio Code, and as you have seen, this is an empty folder, and I advise you that you work with a GitHub repository, Git and GitHub repository, and where you can commit and push your code. But here, let's get started with creating a virtual environment to your previous virtual environment if you already have one, so don't do uv then. Okay, but then source.then been activated, and now when we have activated it, we just install the stuff we want. Pip install matplotlib, of course, and ipy kernel. That is all that I need for this lecture. And then we'll create matplotlib basics.ipynb. Okay. So then I will close down my terminal as I'm done with that one, and I will create markdown matplotlib, change this to Python, my virtual environment. Yes. And now I'm ready. And when installing matplotlib, I think NumPy is installed as well, right? So let's try import NumPy as np. Yes, import matplotlib.py plot as plt. Okay, so let's create x equals to np.linspace. And here we go -5,5, and then we type out x, and you can see this is actually 50 numbers. How can I know that? We do x.shape, and then you can see it's 50 comma, so it means that it's one dimension and there's 50 numbers there. Okay, so NumPy is used for doing computations and creating arrays, and it's really fast to work with it. So it's better to use NumPy than lists when you want to do some computations. Okay, so we have created x, and let's create y as well, or f. F equals lambda x, and then p.sin of x, for example. So there's a lot of mathematical functions inside of NumPy. So let's use this to plot now. And then we have different ways of plotting. So we have first, let's create a markdown here, lab style interface. NumPy and matplotlib is highly inspired by MATLAB, which is another language. So here we use the MATLAB style interface to plot. And you may see this a lot in different tutorials and probably in many LLMs, as LLMs are trained on internet's data. And in the internet's data, there's a lot of MATLAB style interface for matplotlib, as this has been around for a very long time. But I advise you not to use it. Okay, so how to use this one? It's plt.figure, and then we can choose the DPI to see how much dots per inches, like the resolution of this. So for example, 200, and then we can do plt.plot, and we do xf of x. And here you have your figure, and as you can see, it's a little bit pointy here. And the reason for that is that we only have 50 points, right, in our x. So if we, for example, copy this one and we paste it here, and then we do, for example, 10, then we have 10 evenly spaced between -5 and 5. And if you run this one, you see it's much more pointy because we have less points. And what it does is that it gives 1 point here, 1 point here, and then it connects with a line. And to show you that, I will show you with another style. For example, here you have --o. And you can see here are the actual data points. And these dashed lines between, we don't have any data. So it's just a way of Matplot connecting the data. So what you can do is increase the numbers here. If you increase to 20, you can see, yeah, it becomes more curvy, right? And if you want to have it 100, then you can see it's very smooth. And we can now remove the dots here, like this. So now you can see it's very smooth, but actually in reality, there's a lot of small points and then there's lines in between. So that is how it works. So what you can continue here is plt.xlabel, and you can say x and copy this one, plt.ylabel, and you call it y, and plt.title, and you can call this sin of x. And actually I can do it with something called latèche, because now if you write sin of x, this is normal text, but if you do backslash sin of x, you need to add dollars as well, and then you come into latèche mode. Let me see. And you need to have back curly braces here. So this is latèche mode. It looks a little bit different. You can have parentheses as well, or you can skip the parentheses. It looks a little bit different. So this is the latèche style, and with latèche style you can also do to the power of 2, and you can see it's in the top of the position. Otherwise, if you don't have latèche style, then you cannot do that, because then you will only have this angle here. However, this is latèche mode, so we can do that, but actually this is sin x, so I will remove the x square just to show you that it's possible. Okay, so this was the MATLAB style interface, and if you get code from LLMs like this, don't use it. Instead, you can rewrite this very simply to the OOP approach. This is what I prefer, and it's much cleaner. And for the OOP approach, I will actually teach you what OOP is later on in coming lectures. However, just stay tuned that you can reuse a lot of things with these methods. So fig, x equals plt dot subplots of 1. And what you get here is you get a plot like this. And then you have this ax instance or ax object, and this ax instance has a lot of methods and attributes. And these methods and attributes, you can call them. So for example, we can call the plot, we can call x, f of x, and then you get this plot. Okay, and now it may look like similar to the PLT style, right? plt.plot. However, you can do something like this, x.set. You can do x label equals to x, y label equals to y, title equals to, let's do latèche, sin to make it similar as before, sin x, latèche mode, and you can see this is same as before. However, now we use the OOP approach, and you can see that we've set here, we can put in several arguments at the same time, and we get these results here. While when you use the PLT approach, you see you have to call PLT on X label, PLT on Y label, PLT on title. And it becomes even more messier when you work with subplots. That is, you have, for example, we could have 4 plots in one figure. And then when you're working with the MATLAB style approach, it's harder to move between the figures. While in the OOP approach, it's much simpler. Yes, so let's continue now with subplots to show you that. Subplots. Let me see, yeah, like this. And we could do like fig, x equals plt.subplots 1, 2. Then we get 2 windows, 2 axes. So this is x0, x1. And then we can do fig size. So we change it to 16,4, and these are in inches. So then it becomes like this. And this you can experiment a little bit, and if you want to change the DPI, you can change it to 200, then it's more dots per inch, so high resolution. And if I want to access the first one, so x.0.plot x, np.sin of x, and we get this plot here. And if I continue here, copy this one, I want to have np.cos of x, and you can see cosine of x like this. And we could set x of 0 dot legend. And here we could add, we could actually do it like this, labels equal, or label equals to sin of x. Yeah, exactly. And then you can do comma label equals cos of x. Like this. And you can also do the first one, so x1 dot plot and x comma np dot cos of x, cosine of x, and now you could do the set, so x0 dot set, and let's see, sin of x and cos of x. Copy this one. To copy it quickly, you do Shift Alt Down button. So if I do Shift Alt Out button, I copy it. If I do Alt button up and down, I just move this up and down, right? And this is just cos x, and similar as before, you can do, let's see, x.set. You need to have title here actually, title. And we can do x label equals x, y label equals y. Like this. Okay, so these were some very simple charts. I've only showed you line chart here, but if you want to learn more about other charts, there's my data visualization course, and where I go into several charts and I go into how to style your charts to make them look really nice. And let's see. This is 0, right? I want it to be 1. Okay, now it works. Okay, good. Yes, and I advise you to work with Git and GitHub repositories so that you commit and push this code to your repo. And I hope that you learned a lot here. We've gone through how to use the MATLAB style interface to plot using PLT and several things. And then we went on to going into more OOP approach, where we had a fig and an axe. And then using the axe, we could do a lot of different plotting. We could set different parameters, etc. And this is basic fundamentals of matplotlib. I have a more advanced detailed course in data visualization, which you should check out if you're interested in learning more. So thank you for this video. See you. Bye.